Today, I'm going to talk about how we can deploy an AI model on a GPU as a asterisk, serverless endpoint, using RunPod. In this tutorial, I'll show you how to create a Python handler that loads an AI model and runs it on a GPU in the cloud. This approach is very useful if you want to build scalable AI applications without managing your own servers. The model I'm using in this example is BRefNet, which is an AI model designed for image segmentation and background removal. Instead of running the model locally on a machine, we deploy it to a GPU environment so it can process requests much faster. The first step is to write a Python handler file. This handler acts as the main entry point for our serverless endpoint. Whenever a request is sent to the RunPod API, this handler receives the request, processes it using the AI model, and returns the result. Inside the handler, we start by loading the required libraries, such as PyTorch, transformers, and image processing libraries. Then we load the BRefNet model from Hugging Face and move it to the GPU so it can perform inference efficiently. Once the model is loaded, the handler waits for incoming requests. When a user sends an image URL, the handler downloads the image, processes it through the model, generates the segmentation mask, and returns the processed result. To run this in RunPod, we package the handler inside a Docker container. This container includes all the required dependencies, such as Python libraries and system packages. After building the Docker image, we push it to a container registry and connect it to a RunPod serverless endpoint. RunPod automatically provisions a GPU when a request arrives. The handler runs the AI model, processes the request, and then returns the output. Alright, so the next step is to create a template for our deployment. First, we go ahead and enter a name for the template. This name just helps us identify it later, especially if we create multiple templates for different services or models. Now, if you want, you can actually publish this template as a public template so that other people can use it as well. But in my case, I'm going to keep it private since this setup is specific to my project. Next, we need to select the template type. Here, I'm choosing serverless. This is really important because serverless significantly reduces GPU costs. Instead of running GPUs continuously, the system only spins up a worker when a request comes in. When there are no requests, the worker is shut down, so you're not paying for idle GPU time. After selecting serverless, the next thing we need to do is enter the Docker image path. This is basically the container that contains all the code and dependencies required for our application. So we paste the Docker image URL here, which tells the platform exactly what environment to run when a worker starts. Now, in my setup, I'm also saving the generated data to Cloudflare R2 storage. Since the application needs access to that storage, we have to configure some environment variables. So what I do is add environment variables for things like the R2 endpoint and bucket name. Then I add secrets for sensitive values such as access keys and secret keys. Using secrets is important because it keeps credentials secure, instead of exposing them directly in the configuration. Once all of that is configured, the template name, serverless type, Docker image, and environment variables. The template is basically ready. And with that, our serverless template setup is complete, allowing the system to automatically spin up GPU workers only when needed, while securely storing data in Cloudflare R2. Now click on Save Template. Alright, so now that the template is ready, the next step is to create the endpoint that will actually run our service. To do that, we first go to the dashboard and click on New Endpoint. Once we click that, we choose Custom Deployment because we want full control over how our container runs. Inside the Custom Deployment options, we select Deploy from Docker Registry. This allows us to use the Docker image we built earlier, which already contains our model, dependencies, and server code. Next, we need to select the GPU configuration. This is an important step because the GPU determines both performance and cost. Here, I'm selecting the RTX 4090 GPU. The reason I choose this is because 4090 GPUs usually have a higher supply available on the platform, which means jobs start faster and the pricing is generally more stable. After selecting the GPU type, we proceed to configure the worker scaling settings. For the minimum workers, make sure to set it to 0. This is very important when using serverless workloads because it ensures that no GPU is running when there are no requests. In other words, you won't be paying for idle GPU time. Then for the maximum workers, I'm setting it to 3. This means that if multiple requests come in at the same time, the system can automatically scale up to 3 GPU workers to handle the load. However, a key thing to remember here is, if you increase the minimum workers to 1, the platform will keep 1 GPU running all the time, even when there are no requests. And that means your GPU cost will start accumulating continuously. So keeping minimum workers at 0 is the best approach for cost-efficient serverless deployments. Once all these settings are configured, GPU type, worker scaling, and deployment source, we can finally go ahead and create the endpoint. And that's it. Now our serverless GPU endpoint is ready, and it will automatically spin up GPU workers only when requests come in, giving us both high performance and optimized cost. To do that, we go to the RunPod endpoint dashboard and open the request tab. Here we can manually send a request to our serverless endpoint. In this example, I'm going to send the image URL from Cloudflare R2 storage. Since our images are already stored in R2, we just copy the public URL of the image and paste it into the request body. Once everything is ready, we simply send the request. Now if you look at the status, you'll see that the request initially shows queued. This is completely normal when using serverless GPUs because the platform needs to spin up a GPU worker when the first request arrives. After a few seconds, the worker starts, the model runs, and now you can see the request status has changed to success. That means the processing is completed. Next, we can open the result URL returned by the endpoint. When we click that link, you can see the background remove image generated by our model. And just like that, our serverless background removal API is working perfectly. If you found this tutorial helpful, if you have any questions, drop them in the comments below. And make sure to subscribe to the channel for more AI, cloud, and developer tutorials like this.